So now we will study the very important and most confusing part of the assembly language programming. That means that how do we specify the operands in the instruction? So that specifying the different operands in the instruction, we will call by a popular name as called as addressing modes. So they are called as addressing modes. So if you understand the addressing modes, writing the programs in ALP is very easy. Let's understand what is an addressing mode. If I write any instruction in assembly language, the operands are specified in a different way. Sometimes operands are registers, sometimes operands are memory locations, sometimes operands will be the number. So different techniques are there, the way I can specify the operands. So this we can generally call as technique or method of specifying the operands, specifying the operands in the instructions. So we will learn them. So one by one, with an examples. Let's take the first one now. So what is called as immediate addressing mode? Immediate addressing mode. Now we will give an example. I'll give an example, then I'll specify the way we specify. What is an immediate addressing mode? Whenever I write an instruction, let's say move some number 200 into a register R0. So this is called immediate. That means that instruction contained a number which is explicitly specified in instruction. We use an hash symbol in most of the assemblers to indicate the number is what? 200 is what? 200 is the data which is required as a part of the instruction. For example, if you write in a high level language, so for example, if I write a number I is equal to j plus c 6 in a high level language, how do you convert that in assembly language? First, I have to load the number into one of the registers and then add the contents of that register memory location. That means that I will write like that: move since number constant into some register R0. So that means that whenever high level language contains a constant in the program, the way to specify the constants in the assembly language is what? Use the immediate addressing mode. So immediate addressing mode. Most of the processors specify as assigned numbers. So that means that if the 32-bit number, 32-bit is the number you can represent in an instruction, means the 32-bit can be signed number also. It can be generally represented in a 2's complement format. So positive numbers will be written directly with the last bit indicating as a signed bit. Negative numbers will be represented in the 2's complement. The last bit becomes a 1. So this is one addressing mode. So let's go to the second addressing mode. We call it a register addressing mode. Register addressing mode. In this case, the instruction explicitly mentions some registers for the operation to be performed. Let us take an add instruction. Add. We already use this instruction in many places. Add 0, R1, R2. So that means that I am specifying the registers as a part of the operands. Whenever you specify the register as an operand, we call it a register addressing mode. So for example, if I ask the question in this case, what addressing mode here? Here one of the operand is immediate, other operand is what? Register. So that is the meaning of a register addressing mode. Let's move to the third one. Direct addressing mode. Direct addressing mode. So the moment when I say direct addressing mode, sometimes in some books and also some processors, they use a word called absolute addressing mode. It's also called absolute addressing mode. So in a direct addressing mode, the moment direct addressing mode comes, you should be able to understand that it is the memory location is referred in the instruction. So memory location is referred in the instruction. Now, how do we refer that memory location? Let's take an example. So again, I'll use move instruction here, move location to R2. So what does it mean that? I am referring inside the instruction a memory location whose name is what? Location into the R2. Some processors, you can directly specify the address also. You can write move 2000 H hexadecimal into R2. That means that 2000 is what? The memory address. From there, I'll moving the value into the R2. That means that I can refer this as what? The contents of location is moved into the R2 register, or here I can specify the contents of memory location 2000 is moved into R2. See the difference here. In this case, a number is referred here. In this case also a number is referred here. It's a very different here. In this case, the number what is specified is an immediate, that is hash symbol is used. That means number is a part of the, it's a number. It's not an address. When hash symbol is not used, the number whatever I indicate here, it meaning is what? It's a memory address. That means that if this is the processor, if this is the processor contains a register called R2. If this is a memory location and the memory location contains a location whose address is 2000H, let's say I have a 75 inside that one. So when you execute this instruction, what will happen? 75 will be moved into the R2 register. Whenever you use a move instruction, the source data will not be disturbed. That means that whatever there in the 2000H 75 will not be disturbed. Only copy of that is moved into the R2 register after the execution. This is what will happen. Whereas if I write this instruction in a memory, so the processor and if I say the memory, both the instruction move, the instruction and the number, that means that move instruction and the number, whatever the 6 are stored part of the memory itself. Both are in the memory itself. But what will happen? The number is moved into the particular place. For example, in this case, it's moved into the R0. So then what will happen? This number is moved into the R0. So whenever immediate means the number is a part of the instruction. Whereas here, where is my data? In this instruction, where is the data? It is not in the instruction. When I write this instruction, yes or no, into the machine language format, let's say opcode is there and this 2000H is there. Yes or no? But the data is not there in the 2000H. 2000H, what does it contain? Only address. So, but what data is moved? The contents of 2000H will be moved into this one. So that means the data what is present in 2000H is moved. Here what? The data 200 itself is moved here. That is the difference between immediate and a direct addressing. Always think that direct addressing means it's a memory. Whenever you want to read, write something to the memory, if you know the address, I can always use a direct addressing mode. Only thing is you should know the name of the location or should know what is the address of the memory location. Then you can use this addressing mode. The fourth one. The fourth one is difficult to comprehend. Let's say now I want to add set of numbers. Let's go back to the next screen and then we'll come back to here. Let's say I want to add set of numbers. So my numbers are there in the memory location like this. I have following numbers available: 10, 20, 30, 40, and some 60 numbers are there. I want to add these numbers. How do I add the numbers? Let's say address of this location is 0. Address of this is, let's say, 4. So 8. So then it is 12 because I'm taking one word. One word is a 32-bit. I'm taking it. Let's say is there. How do we add it? So we add instruction first. Add. So address called 0. Then I'll be storing into one register called R0. Now what will happen? Since 0 is what? 0 is nothing but the memory address. So 0 is a memory address. I'm storing it. Then the answer, that 10 is now stored in which register? It is stored in the R0 register now. So now it has become a 10. Now again I add another instruction. Add. So 4 is another memory address into R0. Now whatever the 20 is there, I add it to that. So 10 becomes now 20 plus 10. It becomes 30. Similarly, I write add 8 to R0. So similarly, I'll write another 2 instructions. So 12, 16 into R0. So that means that I can repeatedly write many add instruction to add the set of numbers. Ultimately, it contains what? 10 plus 20, 30, whatever the numbers is there contained. But this method of writing the program takes lots of instructions, and the existing addressing modes, whatever supported till now, it does not support to simplify program. That is, direct addressing mode is not the solution to simplify my program. Now what should I do? Think about this instruction. Let's say I have an instruction add. Now answer is always stored in the R0 register. This is the place I should be able to indicate the first time in the loop, what should come here? 0 should come here. Second time it should come with what? 4. Second time, the third time in the loop, it should contain 8, 12, 16. That means that one of the operands in the add instruction should have the capability to change the contents of that operand every time I run in the runtime. That means that if I'm able to repeat this add instruction many number of times, so how many times? Let's say 5 times. Every time I execute it, each time the address what is specified by one of the will keep changing. So this is not possible in a direct addressing. So they provide one method. What is the method? Now, if I indicate this address in one register, the contents of the register will give the address. Then every time I add, I'll change the contents of the register. Then it is possible to use one single instruction, the looping. Let's do that one now. Let's say add. Now I use an R0 register now. If I just use R0, it is a normal value of the R0. Now I'll put a bracket here. So when I say bracket here, the meaning is different here. So let's understand this now. So I will use another register, which is because R0 I use for something else. Let's say add R1, comma R0 I specify. So what is the meaning of this instruction here? Now here, when I execute this instruction, it is going to add the contents of R0 to the memory location, So R0, the contents is there, something is there, let's say 20 is there. I want to add to the memory location now. Now, whenever I say bracket around the R1, that means that it is not the contents of R1 I'm adding it. If I write directly add R1, R0, so what is the meaning of it? I'm directly adding, so I think it's resetting, I just add back. So I was just discussing about whenever I write add instruction, there is a method to specify the address dynamically at the runtime. For that, we use a technique called indirect addressing. So let's understand how does it work. Now, let's say this is the instruction. Now I have some value is available in the R0 register, some 20 is available. Now I want to add the contents of R0 to a memory location. Now, the memory location is not directly specified in the program, but it is specified through some other means. What are the means? R1 is used here. So whenever I use the instruction like add R1, R0, what is the meaning of it? I'm adding the contents of R1 to the R0 directly. But when I use a bracket, the contents of R1 will have a different meaning. So if I don't use a bracket, the meaning is what? It is a contents of R1 is used in the program. If I put a bracket, the meaning is different. That means that R1 acts as a pointer. So this is the concept of how the pointers are implemented in assembly language. When I say direct addressing, if I refer 2000 in the instruction, any assembly language instruction, that means that what? It is declaring a variable in the high level language. So declaring I, J, like that variables. Whenever the pointer is required, why do you require a pointer? Because at the runtime, I want to change the address which I'm referring to the memory so that I can able to make my program simple. I can loop my instructions. So whenever we want to declare a pointers, always identify any one of the registers which can be used as a pointers. In Intel, there are only certain registers are there which can be used as a pointer. In ARM, all the registers R0 to R31, any of the registers I can use as a pointer. So now let's use a register, any general purpose register. Assume that any of these registers are available for as a pointer. Now, if I write like this, so that means that I am accessing them as a pointer. Now R1 contains, let's say R1 contains 2000 before execution of the instruction. Then what is the meaning it carries? That means that I am adding the contents of the memory location which is referred by R1. So in this case, so that means that 2000 is the stored in the R1 register which points to the memory location 2000 in the memory. Let's say 2000 is this memory location. We are referring to this one. Let's say it's content 10. Now, so I am adding in this case 10, which is nothing but what? 10 is nothing but contents of memory location 2000, or we can also write this like this. R1, contents of R1 refers to memory location. Contents of that is nothing but the data. So plus 20, my answer is 30. So 30 is stored in the R0 register. So how do we explain this type of instruction is, I can just repeat, add the contents of memory location whose address is specified in the register R1 to the another operand which is specified in the instruction. So whenever we use this type of instructions, we should understand that always the one of the registers will act as a pointer, and the brackets are used to indicate that R1 does not give the data, R1 gives the memory address. So to that address I have to go there, and that address will refer to some data what is present in that address that we are using in the program. So this is called as indirect addressing mode. So let's go to the next type of addressing mode. So now, so the fourth type of addressing mode, what we studied now is called as indirect addressing mode. Sometimes we also use a word called register indirect addressing mode. Indirect addressing mode. So in this mode, so the example is at any of the register, you can use it. Specify that one. So I use the bracket. I use the bracket 2 times. Then I specify the R0, and the answer is stored in the R0. So this is one of the method. So this is very useful when you want to do any operation on set of numbers, on the set of numbers. Any task you want to repeat multiple times, I can able to use this one to do it. Now what we'll do is, before we continue the fifth one, we will write a small program for this instruction and then continue. So now before we continue, write a program. So I will continue with the program first. Write a program to add set of n 32-bit numbers stored in the memory. So let us understand this addressing mode by writing a small programs. Now, as I said, a program is a set of instructions. Program is also a set of data. So that means that I require to store both my data and the instructions in the memory. So now let's store this both the data and this one in the memory. So I will write down the memory picture. I'll start writing the numbers. Now, when I write a program, finally I'll get an answer. So I will store the answer in a memory location. I'll call the name of the memory location sum. So then the program says there are n-bit numbers are there, n 32-bit numbers are there. So I will store the value of that in one memory location called as n. So I will store n. So now this contains 32-bit numbers. So I will be referring each of the numbers by a name called num1, the first 32-bit number, num2, second 32-bit number. Like this, I will store many numbers in a memory location. Up to n numbers, I'll be storing it. So this is the data related to the program now. Now, where is my program is to be stored? I have to write a program in the memory itself. I have to write my program here. Now, so this program is also there in the memory. This data is also there in the memory. So now we will start writing the instructions for that. So what is the first thing I supposed to do it? I should able to take one number, that is take the n into one register, so that I'll be knowing that how many times I have to repeat the same addition operations. So I will use the move instructions. Move instruction. I use a n and then R1. Each time I write an instruction, please guess what addressing mode it is. If somebody asks what addressing mode it is what addressing mode it is. Can you guess? So n is nothing but what? It's a memory location. It's a name. Name means what? It's nothing but some address, 1000 like that. Whenever memory address is directly specified in the instruction, either the name or address, then it's called as a direct addressing mode. So we understood it's a direct addressing mode instruction. Now, register called R0, which is present inside the processor. So which holds the cumulative sum of all the numbers. So either I can use move to start with #0 into register called R0. So I'll be making the R0 register which holds the answer to 0. What addressing mode it is? It's an immediate addressing mode because I'm storing 0. I'm indicating a number into this register. Now, so now I require a particular operation. What operation? Add operation is particularly required, which will be repeatedly executed on the set of n numbers. So that means we know that whenever we want to repeatedly execute a particular operation, we require what is called indirect addressing mode is required. One of the register I should use as a pointer which holds the address. So now I will choose any one of the register as pointer. Let's say I'll choose R2 register. I'll do R2 register as a pointer. Now what does the R2 should contain? R2 should contain first address of the first memory location. So R2 register should point to the first memory location. So move address. I know the address. What is an address of that memory location where the first number is stored? Num1. So I'll say #num1 because anytime you represent the number. Now what is the number? Num1 is an address. For example, if 1000 is there, so this is 1004. 1004 is what? A number. I am not interested in what is there in 1004. I am interested in the number 1004. That is nothing but number. That's why I put #num1 for R2. So what addressing mode again it is? It's an immediate addressing mode again. Now I'll start my logic. So what is the logic? My basic logic is now what? I have to use indirect addressing mode. And the pointer is stored in the register R2. I am storing all the numbers into register called R0. So what is this instruction will do? Add the contents of memory location pointed by the R2 register. Now where it's pointing? It's pointing the first number. It is taken and added to R0. Now one number is added. Now I have to repeat this addition. Whenever I want to repeat it, I should be able to set my pointer properly. So what is the pointer value now R2? R2 contain now 1004 because every word is nothing but 4 bytes. So where is the num2 is stored? 1008. Where is that? So the next number +4, it will continue like that. That means that before I start repeating the same instruction, I should increment R2.4. So I'll add number 4 to R2. Then what will happen? Pointer now R2, which was pointing to the first number, R2 will point to now what? The second number. Now you are able to the pointer appropriately. But can I repeat? Now can I go back? Can I go back to the first instruction I had? Can I start now immediately? No, I should not do it. Because why? This operation should be repeated how many times? N times. How do you know that whether I finished n times or not? For that, we set up a counter. You already set up a counter called R1 register. What does R1 contains? N is a value contained in R1. So since one operation is completed, I'll decrement the value of R1 by 1. So I will decrement. Actually, instruction can be DEC also. Instead of writing decrement, you can write DEC. So decrement R1. So what is the meaning of this instruction? New instruction, what we introduce? It is reduce the contents of R1 by 1. You can also write subtract #1 R1 also you can write it. That means that I'm subtracting 1 from a 1. I use a decrement instruction. So now after decrementing R1, I have to check whether R1 has reached the value of 0 or not, because R1 is loaded with the value n. How do we do it in assembly language program? We'll discuss that in detail tomorrow, but I'll write the instruction branch greater than 0 and to the loop. What does it mean that? So I am executing an instruction called branch instruction. The branch instruction will check whether the previous instruction has produced 0 result or not. Always the processor will have the capability to indicate what happened in the previous instruction. So any instruction you execute, you can know what happened in the previous instruction. In the previous instruction, you decremented the value of R1 by 1. So R1 in the beginning, let it be 4, 3, 2, 1, 0. That means that the branch instruction can know that the previous operation has resulted in a 0 or not 0. If it is not resulted in 0, that means the previous answer is greater than 0. I will loop back. Loop means what? This instruction brings the control back to this instruction. Now you keep on repeating this instruction. How many times we repeat? Until the contents of R1 becomes 0. So once the value, once the R1 becomes 0, it will not continue here. It will come back to the next instruction. So what is the next instruction? We have to do it. We know that the answer is accumulated into the register called R0. So I have to store that answer back into another location called sum. So I'll be storing move instruction. My answer is in R0. I'll move into sum. So what addressing mode it is? This is register. This is direct addressing mode. What addressing mode is this one? Indirect addressing mode. What addressing mode is this? Register. So what is this? It's an immediate. That means that looking any instruction, now you should be in a position to tell, is it immediate addressing mode? Is it a register addressing mode? It's a direct addressing mode, or it's an indirect addressing mode. So this is a complete program, how you can able to write a program in a machine level language. So now I have written a program in a machine language to able to add a set of n numbers. So I use the instruction move, add, decrement, and a branch instructions. At the same time, I am able to use the different addressing modes. Summarizing, addressing mode is what? Is a technique of specifying the operands in the instruction. Sometimes operands will be registers, sometimes the memory, sometimes is a memory but indirectly specified. So you can specify the pointers also, you can specify the direct address also in the memory location. Now, so we will continue for another 10 minutes. So what we do is now the next addressing mode, we'll go to the next addressing mode. So 4 addressing mode we have studied. So now we will go to the, so another addressing mode, which is the 5th addressing mode, which is very commonly used or required to implement arrays, 2-dimensional arrays, so or arrays which are indexed and arrays which are located at different locations in the memory. I want to index into the arrays, we can able to use it. So we will see that how we can able to use that addressing mode. So the 5th addressing mode. So the 4th one you use to add set of numbers. If you want to repeatedly do certain things, you can use it. Now the 5th one is called as indexed addressing mode. Indexed addressing mode. So I'll give the instruction example and then we will analyze that instruction by a simple program. Add 4 or 0 into R1. Here the actual address, memory address, because when I say bracket, R0 is what? It's a pointer, but along with the pointer there is a special number called 4 is there. That means that the contents of R0, what is available, I'll take it. It represents some number. Then since a number is indicated next to that register indirect, so I'll be adding that number, and the total number whatever I get by adding the contents of R0 plus 4 is the actual new address. This type of generating an address, new address at the runtime, we also use word called as effective address. Effective address is nothing but actual address which is obtained by combining many things. So now what are the things I combined here? The contents of R0, the contents of R0 plus another number. So I'll put another bracket. So that contents will be moved into the R1. So we will take an example and do it. So let's say I have a memory and R0 register is inside the processor contains 1000 now. Let's say 1000. Now 1000 refers to a memory location. 1000. Now, so 1000 contains 20. I am not referring to the 1000 memory location. Now I'll be adding another 4 for that. How much I'm adding? 4 displacement I'll be adding. Now when I add 4, so I'll refer to a memory location called 1004. Now it comes to 1004. 1004, I have certain data called 30 is there. Now what is moved? 30 is moved into the register R1 now. So what is the meaning of this instruction? In this instruction, the R0 is a pointer which refers to some memory location, but that itself is not the memory location I'm using to fetch the data. I'll be adding that address to another constant or displacement or offset. We use a word called displacement offset for the number which is specified in the index addressing mode. That displacement or offset is added to the contents of R0 and you will get a new address. That address we call as an effective address. From that address, I'll be fetching the data into this one. So what is the advantage of this type of addressing mode? If your array is located at a particular place in the memory, I can just start the array from that location. I can just add like this, add. So my array is starting from a table, starting at a location called table. I can just refer R0. I can do like this. Whenever I do like this, what does it mean? That I am referring the contents of the memory, so which is pointed by R0. But the memory starting location is where? Table. In the sense, contents of R0 you can initialize to 0. Table can be referred as a address in the sense. So I can just indicate, assume that there is a table is available in the memory table. So from there, all the numbers are available here. So now what I will do is I'll point R0 register to 0 to start with and point to the first location here. Now what will happen? The first time R0 is 0. So what is the table R0 refers? It is the first number it refers. Now I'll increment the R0. I'll retake it's a constant. Now I'll increase the R0 by 4. Now what will happen? Now automatically you are referring to the next number. Now again increment by 4, you're referring to the number. That means that anywhere your data array is located in the main memory, anywhere I can start referring from that reference, I can access all the numbers. So for that, index addressing mode is very commonly used. Index addressing modes are used to refer to the arrays which are located at the different places in the memory. Now what we do is, we will do one small program where explicitly index addressing is used to refer to the data what is stored in the program. So now we will write one more program, the program number 2, to understand the meaning of it. So let's say a list of test scores for n students are stored in the memory location. Now I will not write the program title. I will explain what is the task you're supposed to do it. Now there are n students are there in this case also, n students are available. Now every student will have one record of data. So what is the record present for every student? So 4 words are required for every student. First is student ID, it's a number. Then what is the marks is stored in the test 1, marks is stored in the test 2, and the marks is stored in the test 3. Let's say 3 tests. Now totally how many words are there? 4 words are required, or one record of 4 words is required for student 1. Similarly, I have another 4 words are required. So for student 2, so 1, 2, 3, 4 for student 2. So like this, I have the records for n students are available in the memory. Now, the first address where the first student, the address where the first student data is started is list. So first word, then +4, list +4 is the where the test 1 scores for the first student is stored. List +8 is the address where the test 2 marks are stored for the student 1. Similarly, list +12. So that means that 4 words are required for one student 1 per student, and for student 1 the names of the memory locations where these are stored is what? List is a memory address, or list is the memory place where student ID is stored, +4 is test 1, test 2, test 3. Now I know these addresses. Now what is that I supposed to do it? I supposed to now perform the addition of all the test 1 scores of all the students and store them in a memory location called sum1. I have to store it. I have to store in the sum1 location. I have to store it. Similarly, I have to add all the test scores, test 2 scores of the students in students, I store in sum 2. Similarly, sum 3, I am able to store it. Now, to do this job, now what instructions I have to use in my assembly language program and how to do it. So let's see that. Now, my aim is try to use optimized instructions with an addressing modes. What is we learned now? 5 addressing mode we learned: immediate, register addressing mode, direct addressing mode, indirect, and indexed addressing mode. Let's see that. All we will use it to implement this logic. Now let's start writing the program now. Now first, I will require one pointer to refer to each student ID. So let's say I'll use the register called as R0 as a pointer. I'll make the R0 pointer point to the first record of the first record, in the sense student 1 record. So since the list is an address, the where the first student record starts, I will load list, that is an address. If the address is 1000, I will replace the list by what? Replace this by 1000 with into the register called R0. Now what does the R0 points? R0 is a pointer which contains an address which is referring to what? The first record or the first student 1 record. It's contained. Now I require to accumulate the answers of test 1, test 2, test 3. So that I require 3 variables. When I say variables in assembly language, always you should take registers first. If the registers are always full, no space for the register, then you have to take the memory locations. Since registers are available, I'll take the registers. So I'll clear all the registers. Move, I'll put 0 into the R1 register. I will put 0 into the R2 register. I'll put 0 into the R3 register. Now what I'm doing is I'm clearing all the 3 registers so that I can hold the sums of all the students stored in the test 1, test 2, test 3. Now, how many times I have to repeat this, the whole program? I'm going to write some program. How many times I have to repeat? Depends upon the number of records. Where is the number of records? It is stored in the memory location called n. So I will get that value, that is what is there in the n, into one of the register. Let's say R4. Now what does the R4 contains? R4 contains the number of operations to be repeated. That is how many times you have to repeat a particular operation. Let's write the logic, important logic for this program. Now what is the first thing? I have to add the contents of the memory location. Let's say test 1. Then I have to add the test 1 of the second student. So I should keep on add test 1 marks of the different students. But test 1 memory location is not referred by the R0. R0 is pointing to where? List. But we know that list is 4 bytes away from the list plus 4. So what is the gap between the list and list 4? 4 bytes, I know that. But I know that it is 4 bytes away from the list. That is why I can use index addressing modes. Now I can say 4 R0, R1. So what does it mean that? R0 is pointing to the list. Now, to the R0, how much I'm adding? 4. So that means that I'm referring to what? Test 1. So that means that this says I'm adding the contents of a memory location pointed by R0 plus 4, and that value I'm adding to where? To the R1 register. Now you got the idea. So similarly, I can repeat for test 2. Now test 2 is located at how many bytes? 8 bytes from the list. So I can just say R0. Then I'll put into R2. Similarly, you can guess now. So the test 3 is 12 bytes away from R0. So I can just add it, R3. Now you appreciate why index addressing mode is required. So with directly indirect addressing mode, you can do it, but it requires more number of instructions. If I use index addressing mode, number of instructions required will be less. That is an advantage of choosing a proper addressing mode when you implement the logics. So now I have finished all my operations. Now every time I finish operation, I have to go for the next record. Now, where is the next record? How many bytes is the next record? So we know that 4 plus 4 plus 4, 16 bytes is occupied by one record. Now R0 is pointing to the first record. I should make R0 point to the second record. So how much I have to add? Add 16, that is immediate value, to R0. I should be able to add it. Now pointer will point to the second record. So now I have to repeat this operation. I have to repeat this operation. How do you repeat it? First, I have to find out whether all operations are completed or not. So that is there in a R4 register. I'll decrement the value of R4 by 1. If it is not 0, branch is greater than 0, I'll repeat loop. I'll go back here. I'll keep doing for all the operations. Once I finish all the operations, now whatever the data I have in the R1 register, I'll move to the sum1 memory location. I'll move the data what is present in R2 to the sum2 location. Then I'll move what is the data I have in the R3 location to the sum3. So this is how we can able to write the program to find out, to compute the test scores of all the students. So now I have used in this program all types of addressing modes. I've used immediate, so I've used index addressing mode, so I've used register addressing mode, so I've used direct addressing mode. Here, if you look at this, is a direct addressing mode because the memory location is there. So like this, using simple instructions and addressing mode supported by the processor, you can develop the programs. I think today we have done with the few concepts and how to write assembly language programs. So tomorrow we'll cover little advanced topics and how the stacks, queues, the subroutines are implemented using the ALP programs.